Hi everybody, my name is Bhavishya and in this lecture we will see few concepts. The very first is of what is ASBR, right? And the second concept is that what are the rules to be in the neighborship. Now what is neighborship? So in brief, if I want to tell you, neighborship is when two routers is in the state of synchronization and then they decide to exchange LSAs with each other. We can say it this way for now. But further, we'll see in detail how neighborship is formed and what are the criteria. So, the criteria we'll learn in this lecture. So, let's begin with the what is ASBR. So, ASBR stands for Area Border Router. What does this mean? Let's see this topology. Okay, if you see R1 is in a state where it is connected to two areas simultaneously. It is in the area 1 as well, it is performing in area 1 as well, and it is performing in area 0 as well, right? So it is acting like a border. So this is known as area border router, right? If you'll go and check the neighbor of it, so it will tell that it has two neighbors, one is from area 0 and one is from area 1, right? So this is the condition that it should be in the it, sh it should be connected with different areas, right? As it is connected now. Now let's jump into the criterias call by which we establish neighborship, right? So the very first we have already learned in the previous lecture, but there I haven't mentioned that it is that concept. So let's revise. So the very first point is to be in a neighborship is that both of the routers should be in the same area. As you remember in the previous lecture, what we did was R1 was in the area 0, but we intentionally changed R2's area from R from area 0 to area 1, right? So then what happened was then it was throwing us an error that mismatch ID, right? So this only happened when we changed their areas. So the very first is that area should be same of both of the routers to be in the neighborship state, right? Now the second one says that their hello interval should be same, right? Now if you look at the hello interval default value, that is 10. So what we'll do in this lab is we will change R3's hello interval from 10 to, let's suppose, 12, right? So let's do it. We go to R3, fast ethernet 0/0 IP OSPF, and then we'll say hello interval and 12, right? Now if I'll go to R, let's suppose here only, show IP OSPF neighbor. As you can see, the dead time is reducing, and eventually it will reduce. Okay, and eventually it will reduce to 0, as you can see, and then the entry will get burst as it says dead time expired, right? So when we manually change the hello interval, so that also triggered our dead time, because if you look at the concept of dead time, so it is the 4 time of our hello interval, right? The default value of our hello interval is 10 seconds, and the default value of dead timer, the dead time is 40 seconds, right? So this was the second criteria. Now also, if you look in Wireshark, so in Wireshark also you'll able to see that. Now let's see via Wireshark. This is a tricky part to go and start the Wireshark sometimes. Come here. Okay, as you can see, the source is 13.0.0.3, which is our R3, sending via multicast address, right? If you go and look at the header part, so it says area ID 0.0.1. It is this area, right? It is operating in area. I will go to the hello packet, and here, as you can see, the dead interval is okay. The hello interval is 12, right? And if you look at the R1, the hello interval is 10. So this is the reason the neighborship got broke, right? Now we'll see the third one. So the third rule says that both of the routers should have same dead timer. Initially it was hello packet, right? But this time let's tweak a little with our dead timer. So configure terminal, after that interface fast ethernet 0/0 IP OSPF, and then we will say dead interval, and we are changing it manually, right? So the original value was 40. Let's suppose we changed it to 38. So, or let's make it 35 or whatever, 42. Let's suppose show IP OSPF neighbor. So we don't have any value, right? Okay, I have to reconfigure it, I guess. Yes. Now you can see it is working perfectly fine. Now we'll go and change. Right. For that, the command is still the same. Dead interval, and then we'll change to something. Now let's suppose we change it to 45. Now we'll go and see IPOSPF neighbor. It is reducing, and as you know what happens in the end, it will drop and the entry will get purged, right? We'll see the same in our Wireshark as well. As you can see, suppose R3, we will see the interval here is 45, but if you see hello interval is 10, and if you multiply it with 4, it is not giving us the default value, so it is manually changed. But if you'll go and see R1, the dead interval is still 40, so it is a mismatch of it. So this is the reason why that it will not be in the state of neighborship, right? So let me summarize of what we have learned so far. So the neighborship rule is, very first rule is, the area should be same. Should belong area 1, and it should also belong area, right? The second one is the hello interval should be same, right? Of both of the routers. Let's suppose 12, the hello interval is 12. It should also have the hello interval 12. Same goes with the third rule, that is our router dead interval. Both of the routers should have same dead interval. It has 40 and it should also has 40, but now it is not in state. So let us reconfigure it. So for that we will go config terminal, after that interface path internet 0/0, and then here from 45 I'll turn it to 40. Now if you look at it, the Wireshark, see with humans. Now if you look at it, this is the R3s, as you can see the router ID, the IP address, I mean both both one the same. Okay, so the dead interval is 40, right? If you look at the one, look at the R1, now they are same. So now it is in the state of neighborship, right? So this was it for this lecture. I hope you enjoyed. See you in the next one.